Hello again, Lecturer Joe here. Today we're going to take a look at diodes. We've got a couple here that you can take a look at. So this is what they look like in real life. Look a wee bit like a resistor with a leg out each end, but we don't get the coloured stripes on them. They're usually just one colour with one stripe at one end. So the diode looks something like this, with a stripe at one end. We can see the stripe here on this diode, silver stripe at this end, and looks pretty much like this. You know, we don't draw our electronic components as they look, we use symbols for them. So the symbol for this diode looks like this, an arrowhead with a line at the end, and the line matches up with the stripe because the stripe is telling us which way round the diode goes. So let's take a look at how the diode behaves. Here we've got our battery and bulb circuit. So we know that the current is going to flow from the positive of the battery through the bulb back around to the negative, and our little bulb's going to light up here. So if we draw the direction of current flow on the wire, it's going to look like this. So let's say that we put a diode into this circuit. We'll just break this circuit momentarily and we'll put in our diode. The question is, what happens now that we've put a diode in the circuit in line with the bulb? And the answer here is not much. The bulb pretty much still lights up as it did before. So let's take a look at what happens if we drop the diode in the opposite direction. Same diode connected in the same place, except this time we've dropped it in such that the arrow head of the diode, of the symbol here, is pointing in the opposite direction from how the current wishes to flow. In this case, our bulb is not going to light up, and that's because there isn't actually going to be any current flow. Here we're trying to get the current to flow through the diode in the wrong direction. So that's our first lesson about diodes. The diode will only let the current flow in the direction that the arrowhead points, and here the current always wishes to flow from positive through to negative. We're working with conventional current flow here, positive to negative, and for that to happen it would have to flow through the diode backwards, and that can't happen. So our symbol for the diode looks like this, and if we want the current flow to go through it that way, that's okay. But if we want the current flow to go through it that way, that's not going to happen. Essentially the diode acts like a one-way valve, only allowing current to flow in one direction, that direction being the direction designated by the symbol for the diode, the arrowhead. As it is here, this bulb isn't going to light up, but there is something we could do to make the bulb light again and to get current flowing. Well, obviously we could swap the diode around back into the direction it was, but if we don't want to swap the diode around, what we could actually do is this: turn the battery upside down. Now that we have turned the battery upside down, the positive is at the bottom, the negative is at the top. Current flow is always positive round to negative, and now you'll see that the current wishes to flow in the direction that the diode is pointing. So now we will once again get a current flow, and our little bulb here is going to light up. So to summarize, a diode is a one-way valve. It will only let the electrical current flow in one direction. The current can only flow in the direction of the arrow that's found on the diode symbol. So as we've drawn it here, current can flow from left to right, but it cannot flow backwards. It's also worth noting that we lose about 0.7 volts across the diode when it's conducting. So if we have battery, bulb and diode in series, if we have 6 volts across the battery, we lose about 0.7 here. We would only have 5.3 volts measured across the bulb. Diodes which need to conduct a large large amounts of current are physically big. So this little diode here might be capable of conducting 0.1 amps. This one may be 1 amp, and this one 3 amps. And it's possible to get diodes that will conduct 10, 100, even up to 1000 amps, but they're physically a lot bigger. Finally, one of the main applications of diodes is to convert AC electricity to DC, and this process is known as rectification. If you're not sure the difference between AC and DC, there's a separate video on that you can check out, and we've got another video coming up about rectification itself.